After studying this module, you shall be able to know what is meta-analysis, learn the scientific process of carrying out meta-analysis, and identify the steps of making a meta-analysis report. With time, we have become so involved in our careers and professional lives that there are times we miss our favorite television serials, or when we travel away for a vacation, one misses certain episodes. When we return back, it is not possible for us to watch each and every episode due to our hectic schedules. How easy and comfortable it would be for us if the television channels could show a summary of the serial and the recap of the episodes briefly, so that we are back to the current scenario of the program and do not feel any gap. Just as a summary or a gist of anything makes things easier to understand, the meta-analysis in the field of research is a similar technique to help a researcher in his or her endeavors. Meta-analysis is a statistics based quantitative method of reviewing literature in a field of knowledge. The method employs comparing and combining the results of related studies carried out in the field of inquiry. One makes use of the existing literature, published and unpublished, to arrive at reliable and statistically guided decisions about the results. One may say that the meta-analysis is the quantitative equivalent of the narrative literature review. The traditional literature review involves reading, summarizing and interpreting research carried out in the field. What is meta-analysis? Defining meta-analysis. The term meta-analysis was coined by Jean Glass for the statistical analysis of a large collection of analysis results from individual studies for purpose of integrating the findings. Meta-analysis is a technique that combines and summarizes the findings of previous research. They are systematic reviews or thorough literature searches that use statistical techniques to combine results across studies. They are used in various fields of medicine, business as well as psychology. Meta-analysis results help synthesize and clarify available knowledge on the relevant field of inquiry with statistical guidance correctly. It is a systematic research synthesis in an integrative summary of the findings of multiple empirical studies and is conducted as research with appropriate methodological standards, with intention of being systematic, objective, transparent and replicable. The meta-analysis enjoys certain advantages over the traditional literature review. Some of them are: the trends in the literature can be quantified. The effect sizes over the number of studies can be combined and the probabilities across the studies can be combined too. This leads to an improved understanding of the range of research in the area. By combining the results of a number of studies, the power of the statistical test used is enhanced. This implies that a number of non-significant findings with similar trends, when combined, may show significant results. The process of meta-analysis compels the researcher to prepare a thorough result analysis of previous researches, thus leading to a more thorough understanding of previous research than a traditional review of literature. Meta-analysis is distinct from a traditional review of literature. A traditional review of literature becomes a meta-analytic review only if it includes quantitative estimation of the magnitude of effects and its uncertainty or confidence limit. The process of meta-analysis begins with defining the question. Defining includes parameters as well as qualitative parameters, that is, population of research studies that is relevant is defined with explicit inclusion criteria the search strategy is documented, the next step is collecting data and bibliography of all eligible studies. Coding data and statistical analysis by using objective, reliable procedures for extracting information from studies is done here, and summarizing the findings by basing the interpretation and conclusion about the findings on analysis of extracted study of information. And then the next step is applying it clinically. The process of meta-analysis can be explicated step by step. First is defining the question. The defining the question includes parameters as well as qualitative parameters, that is population of research studies that is relevant is defining with explicit inclusion criteria, that is substantive and methodological. Search strategy is documented and collection of data and bibliography for all eligible studies is done. The coding of the data and statistical analysis by using objective, reliable procedure for extracting information from the studies is done. And the next step is summarizing the findings by basing the interpretation and conclusion about the findings on analysis of extracted study of information, and of course the last step is applying it clinically. An interesting effect is decided and a thorough search of literature is done. If the effect has already been meta-analyzed, a mixed model meta-analysis may be done, as the one done might have traditional fixed effect based, or another effect could be taken to meta-analysis. As one assembles the published papers, the focus is narrowed or broadened to make it manageable and relevant, keeping in mind the design, population and treatment of the studies. The effect magnitudes are recorded and converted into values on a single scale of magnitude. In a randomized controlled trial, the effect is the difference experimental in the change post or pre in the mean. The study characteristics that might account for differences in the effect of magnitude between studies. The study characteristics are included as covariates like duration or dose of treatment, etc. Method of measurement of dependent variable, quality scores, gender and mean characteristics of the subject like age, status, etc. Separate outcomes are then treated for females and males from the same study as if they are coming from distinct studies. If gender effects are not shown separately in one or more studies, gender is analyzed as a proportion of one gender, like a study of 3 males and 7 females, maleness equal to 0.3. This approach is used for all problematic dichotomous characteristics like sedentary versus active, non-athletes versus athletes, etc., etc. There are some meta-analysts who score the quality of a study in terms of yes equal to 1 and no equal to 0. Published in peer-reviewed journals, experienced researchers, research funded by impartial agency, study performed by impartial researchers, subjects selected randomly from a population, subjects assigned randomly to treatments, high proportion of subjects entered and or finished the study, subjects blind to treatment, data gatherers blind to treatment, analysis performed blind. These are just some of the questions that need to be taken into account. The score is used further to exclude some studies and or include as a covariate in the meta-analysis, but with caution. The value of a weighing factor is calculated for each effect using confidence interval or limits. The test statistic T, chi-square or F ratios with numerator degree of freedom which is greater than 1 can't be used. P-value, if the exact P-value is not available, authors are contacted for it, otherwise P less than 0.05, P is analyzed as equal to 0.05. If P is greater than 0.05 with no other information, one deals with the study qualitatively. For control trials, one can use standard deviation of change scores, or one can use the sample size as the weighing factor as well. Thereafter, a mixed model meta-analysis is performed and confidence limits for everything can be obtained, which is preferably 90%. The clinical or practical magnitudes of the effects and their confidence limits are interpreted. Chances that the true mean effect is clinically or practically beneficial, trivial and harmful are also calculated. The magnitude of the between study random effect as the typical variation in the magnitude of the mean effects between researchers and between practitioners is interpreted. In case of controlled trials, there might be substantial individual responses to treatment, thus one must scrutinize studies and report any evidence of such individual responses. Some meta-analysts present effect magnitude of all studies as a funnel plot to address the issue of publication bias. Published effects tend to be larger than true effects because sampling variations have smaller p-values and p less than 0.05 is more likely to be published. A plot of standard error versus effect magnitude has a triangular funnel shape. Asymmetry in the plot can indicate non-significant studies that were not published, but heterogeneity disrupts the funnel shape. So, a funnel plot of residuals is better and help identify outlier studies. The solution to this meta-analysis is only the larger studies. Finding content. The effects from different studies can be combined only when they are expressed in the same units. In most of the meta-analysis, effects are converted to a generic dimensionless measure. They might be standardized difference or change in mean, percent or factor difference, or change in mean correlation coefficient or relative frequency. Finding content for meta-analysis. The content for meta-analysis can be collected through manual searching as well as database searching. Manual searching involves looking at the contents of journals known to publish articles on a particular topic. Also, references enlisted in the review articles or in already selected studies can also be used. The database searching involves searching through the free text and controlled vocabulary features. Free text searches involve entering the search item one can think of, which when fed in the system is followed by finding the selected field of database for records containing those items. The records are then retrieved without looking for its synonyms. Controlled vocabulary method attempts to consult a subject list or a thesaurus of controlled terms that have specified by the creator of database. The components of meta-analysis. The researches included in meta-analysis are published research articles, abstracts, unpublished studies, conference proceedings or programs, graduate thesis, book chapters, company reports and application. The models of meta-analysis. The random effect or the mixed effect meta-analysis. This model assumes real differences between all studies in the magnitude of effect. The standard deviation representing variation in true magnitude from study to study is called the random effect. One gets an estimate of standard deviation and its precision. One includes study characteristics such as fixed effects, which will account for differences in magnitude of effect between studies, like differences between studies of athletes and non-athletes. More studies are needed for traditional meta-analysis. Traditional or fixed effects meta-analysis is when one should allow for real differences between studies as heterogeneity in the magnitude of effect. Percentage of variation due to real differences is quantified by the I-square statistic. The heterogeneity is tested using Q statistic. The test has low power, so one uses p less than 0.10 rather than p less than 0.05. If p less than 0.10, one excludes the outlier studies and retest until p is greater than 0.10. When p is greater than 0.10, the effect is declared homogeneous, that is, one assumes the differences in the effects between studies are attributed only to sampling variations. This makes it easier to calculate the weighted mean effect and its p-value or confidence limits. The limitation of this model is that it is unrealistic, limited and suffers from problems of statistical significance. Aspects of meta-analysis. Advantages of meta-analysis. Over qualitative research reviews, meta-analysis has the following advantages. It attempts to minimize subjectivity as it is systematic and disciplined. It has explicit methods and procedures at each step. It has a differentiated representation of research findings, and it takes into account of magnitude of effect estimate, not just statistical significance. The meta-analysis also reveals new patterns and relationships and handles a large volume of information in an organized way. How does meta-analysis help? Meta-analysis investigates nature of research and its findings. Magnitude, variability and statistical reliability of observed empirical findings get established. Relationship between findings and study methods or procedures may be understood. Relationship between findings and substantive study features like between interventions or participant sample, characteristics and outcomes may be known. History and sociology of research, time trends and publication patterns may be brought to the fore. Theory building and theory testing can be conducted. However, there are certain limitations to meta-analysis, and some of the criticisms are that it is not applicable to all research. It is viewed by some researchers as overly structured and mechanical for synthesis issues. It might mix incommensurable studies without adequate accounting of their differences. Its results are dependent on the methodological quality of source studies. Documenting meta-analytic research. Meta-analysis reports must include first describing the search method completely, including information sources in detail, including database, registers, personal files, expert informants, agencies, manual searching, etc. Mentioning restrictions, that is the years considered, publication status and the language of publications. Purpose of meta-analysis. A single research study decides the statistical significance of a given effect. The aim of a meta-analytic research is to understand the magnitude of an effect with adequate precision. Since each study produces a different estimate of the magnitude of the effect, meta-analysis combines effects from all studies to give an overall mean effect and other important statistic. Therefore, a meta-analysis summarizes and integrates results from many individual studies, analyzes differences in the results among studies, determines if new studies are needed for further investigating of the issue, generates new hypotheses for future studies, and presents a balanced and impartial summary of the existing research, enabling decisions on effectiveness to be based on all relevant studies of adequate quality. Applications of meta-analysis. Meta-analysis can be applied in different fields like assessing effectiveness of treatments, interventions and prevention programs used in mental health, understanding the gender differences in childhood, adolescence and attitudes, establishing psychometric validity of psychological tests and generalizing psychological tests, carrying out meta-analysis in reality. The step 1 is defining the research question. Propose a conceptual and operational definition of concepts and constructs related to the research question. Example, in meta-analysis of the efficacy of psychological treatments of OCD, constructs such as the disorder, measurement, tools and psychological treatment need to be defined. Step 2 is searching the literature. Define the eligibility criteria for studies and the types of study designs accepted to be included. Example, in meta-analysis on OCD studies, need to fulfill criteria like control group of OCD, treatment for adults with OCD so as to report statistical data for calculating effect size. Identify as many potential studies as possible. Those studies are included keeping in mind the fact that the differences among the studies are minimal, replication of data or studies is eliminated, and this improves the quality of data as well as enhance the validity of the results. Studies may be taken from electronic database like EBSCO or PubMed, relevant journals or books. More than one researchers are involved in this process to reduce the possibility of selection bias. At the same time, one should also include unpublished studies and calculate the number of studies averaging null results, that is, which did not reach significance, to avoid type 2 error. The step 3 is coding the data. Record the main characteristics of the studies included, like the substantive characteristic related to the research question, methodological variables or characteristics related to study design, and extrinsic variables that could influence results without any relation to the subject or study design. Example, substantive characteristics in case of OCD include type of psychological treatment, methodological characteristics include type of design, and extrinsic variables like place of conduction of study, socio-economic background of sample selected. Step 4 is calculate effect size index. As defined, the effect size is the degree to which the phenomena is present in the population. Effect size index that quantifies the result of each study in a common unit, which is then applied based on study design and type of dependent variable. Effect size is calculated using Pearson's correlation coefficient, which lies between 0 to 1. This may be Cohen's d based on standardized difference between two means and or, that is the ratio of odds or the probability of event occurring divided by probability of events not occurring. The statistical analysis and interpretation is the next step. Studies selected are combined and compared to determine the potency of a variable across studies as well as studies that produce significantly different results respectively. Averaging the size effects may be done using any of the models of meta-analysis. The next step is publishing the meta-analysis. In the following format, one can publish the meta-analytic results. Introduction, define construct, objective hypothesis, literature review, methodology, specify selection, criteria, search strategy, coding and statistical analysis. Results, characteristics of the study, effect size distribution, mean effect size and results of statistical analysis. Discussion, results of present study corresponding to previous studies, and last conclusion, which is implication for the future results. Summary. In statistics, meta-analysis comprises statistical methods for contrasting and combining results from different studies in the hope of identifying patterns among study results. Sources of disagreement among those results or other interesting relationships that may come to light in the context of multiple studies. Meta-analysis can be thought of as conducting research about previous research. In its simplest form, meta-analysis is done by identifying a common statistical measure that is shared among studies, such as an effect size, and calculating the weighted average of the common measures. This weighting is usually related to the sample size, and calculating weighted averages of the common measures. This weighting is usually related to sample sizes of the individual studies, and although it can also include other factors such as study quality. Meta-analysis is a statistical literature review of magnitude of an effect. It uses the magnitude of the effect and its precision from each study to produce a weighted mean. A single research study decides the statistical significance of a given effect. The aim of a meta-analytic research is to understand the magnitude of an effect with adequate precision, since each study produces a different estimate of the magnitude of the effect. Meta-analysis combines effects from all studies to give an overall mean effect and other important statistics. Traditional meta-analysis based on unrealistically on using a test for heterogeneity to exclude outlier studies. Random effect or mixed model meta-analysis estimates heterogeneity and allows estimation of the effect of study and subject characteristics on the effect. For the analysis, the effects have to be converted into the same units, usually percent or other dimensionless generic measures. It is possible to visualize the impact of publication bias and identify outlier studies using a funnel plot in meta-analysis.